In this lecture, we will be discussing the different kinds of distillations. There are two main types of distillation, simple distillation and fractional distillation. The difference between them has to do with the difference in the boiling points of two different liquids that are being separated. Simple distillation is better for compounds that have very different boiling points, whereas fractional distillation is used to separate compounds that boil at similar temperatures. If the experiment were to be conducted in class, half of the students would perform simple distillation and the other half fractional distillation. Again, as always, please read the textbook. It's always very useful to get all the information you need in case something isn't covered in the lecture. So what is distillation? In the previous lab, we discussed crystallization, which was a purification technique for solids. However, this technique is not useful for liquids. That is what we have distillation for. Distillation is a process that utilizes the volatility of compounds to separate them. Certain compounds have more volatility than others, and volatility basically means its ability to turn into a gas. Distillation is a heavily used process in industry. For example, you can see here in Ruston Refinery, they are producing gas and oil, diesel and all that stuff. Distillation is also used to make different kinds of alcohols such as wine or beer. So the first type of distillation I'm going to cover is simple distillation. So there are three main components in simple distillation. There's the boiling liquid mixture, which would be in the round bottom flask right here. There's the condensing vapors, which will be found in this section right here. And then there's the collection of the condensate, which is right here. You can see here the different parts of a distillation setup. Here you can see your heating mantle. You clamp your round bottom flask onto the heating mantle, and then you add this three-way adapter onto it. You attach a thermometer to the top. I'll go over this right now. And then you connect this three-way adapter to a condenser here. So some important features to look out for when you're setting up a condensation is you have to have your water coming in from the bottom going up to the top. So there's a tube surrounding the inside condensation pathway, right? You have the water cooling this glass inside in order to let the vapors condense into liquid. And the liquid just drops down here into a collection flask or cylinder or whatever. Usually you want to use a graduated cylinder in order to be able to measure the volume of what you got. One other thing to point out here is you'll notice here the thermometer. It ought to be below the opening right here. You can see that right there, the bulb. This is very important so that you monitor the correct boiling point of the liquid. Now you notice the thermometer does not touch the liquid itself because the vapors on top should be the same temperature as the boiling liquid. That is one of the defining features of boiling point. So how does simple distillation work? Well, one of the important things, as I mentioned earlier, is you need two liquids with very different boiling points, otherwise they won't separate with simple distillation. You can see here an example is methanol and water here, right? You have methanol boiling at 65 degrees and water boils at 100 degrees. So when you start heating your mixture of solvents, the temperature and the thermometer will start to rise as soon as the steam from the solvent starts to rise into the thermometer. You'll notice that once the boiling point is reached, the temperature will stop rising or it'll go very slowly. At this point, you're at the boiling point of the first solvent coming out, which is in this case the methanol at 65 degrees. And you'll start to see droplets forming on the condenser, and then they'll start to drop here. Once all of the methanol is gone out of the solution, you'll notice that the temperature starts to rise again, and at this point it'll stop at the boiling point of the higher boiling liquid, which in this case the water is 100 degrees Celsius, right? So at this point the temperature will also stop rising, and you will notice that the more droplets start to form here on the condenser, and you start collecting them in not the same graduated cylinder, a different one, to measure the volume to get your percent recovery. Uh, One important thing to note is you never want to boil this flask until it's completely dry, because, well, in this case we have water, so it's not that dangerous, but other solvents, if you do that, they could explode. So that's a safety issue to be aware of. Now, a second type of distillation is known as fractional distillation. You can see here there are four components to the fractional distillation. There's the boiling liquid, of course, the fractioning column, which is different from simple distillation, and then you have your condensing vapors again in the same area right here, and this collection flask, right? Or in this case, a graduated cylinder again. Uh, Pretty much the same thing, right? You have your thermometer here, your through-way adapter, your condenser with water in at the bottom. Everything is the same right here as simple distillation. And then you reach the fractioning column. And I'll go over on the next slide how this works. Basically, you want to have little collections of droplets of mixtures here. The higher up you go, the purer the mixture gets, until you have more, pretty much just one solvent at the top. And of course, you have your round bottom flask and your heating mantle. Again, the assembly is the same, right? Except for the addition of this fractioning column. Okay. So, going on to how it works, the fractioning is in order to properly separate two liquids with very similar temperatures. The fractioning column basically creates fractions, right? So you have your rising steam. It's got a mixture of solvents, right? Because they're going to boil at very similar temperatures. But then they start to condense in these little pockets on the fractioning column. Uh, the higher up you go, the more pure the vapor is of the droplets, because these droplets are getting cycled, right? They're condensing and then they're re-evaporating, or re-vaporizing, and then it keeps happening and it repeats until only the the lower temperature mixture, the solvent comes out of the fractioning column here, okay? So here's the procedure to be followed, right? You can see in this image the image of the real parts that you would be using in the distillation. You have your thermometer here with the adapter to put into the three-way adapter, right? You have your condenser here leading into a graduated cylinder. In this case, you would use a 10 milliliter measuring cylinder. These are also known as graduated cylinders. You have your round bottom flask. In this case, it's a 50 milliliter one. You have your heating mantle here, right? And then there's two more components here. I'll go over them in a moment. So the first thing you want to do before putting any of these glass parts together is to grease them. Now, why do you grease the things? It's because two reasons. You don't want the vapors escaping from between the glass joints. So that can happen if you don't grease them. And also, if you don't grease, things can get stuck together. And they're really hard to pull apart. You don't want to get them stuck together. Okay? You start the experiment then by adding 10 milliliters of methanol and 10 milliliters of water into the round bottom flask. And you add 2 to 3 boiling chips. Boiling chips are basically these little black rocks, basically. And they are necessary because if you don't add them, you'll end up getting a superheated fluid here, right? And then if you shake the flask or something, it'll violently boil and spill over hot liquid, right? We don't want that. So the boiling chips add little holes, nucleations, to be able to form bubbles so that it can gently boil without violently spilling over, right? The heating mantle always needs to be connected to a transformer. This is necessary for safety reasons and also to be able to control the heat of the heating mantle. This is a fancy one, but the ones that we used at UTEP, they didn't have this dial here, so they needed to be controlled with a transformer. One other thing is this O-ring, right? This is actually to hold the heating mantle up against this round bottom flask. You want to do this so that you can quickly lower it in case this starts to boil too vigorously, right? One other thing to mention is you want to put a clamp on here, this round bottom flask, and another clamp holding this condenser here. These things can go without being clamped, they're fine. They don't weigh much. But the condenser and the round bottom flask need to always be clamped, right? And in this specific procedure, you would dial to 50, right? The temperature. Moving on to the fractional distillation procedure, the first thing you want to do is prepare your fractionation column. Basically, you use a regular condenser and you pack it with this copper, very thin copper wiring known as copper wool. This will be where the little pockets, the fractions are made, right? The little droplets will start condensing and then revaporizing to form the fractions that'll purify the distillation, right? Basically, you're doing the same amount, 10 mLs water, 10 mLs methanol, and the 2 to 3 boiling chips. The heating mantle is the same, right? You clamp the round bottom flask and the condenser, and then you put an O-ring under the heating mantle to be able to lower it and raise it. The reason for this is actually because you don't want to be moving all of these other clamps, right? You want to have one thing that you can move quickly in case it gets too hot, right? But that's basically it. That everything else is exactly the same except for the preparation of the fractionation column, right? You don't really need to clamp this because it'll be on top of here, but this one does indeed need to be clamped. And of course, you collect your distillate in 2 different measuring cylinders here, and that's basically it. So the next step is carrying out the distillation, right? So the instructions are pretty much the same for both types of distillation. The only difference is how long it takes, right? The fractional distillation takes longer because you have to go over a longer tube. Now, the first thing you should note, you have to attach cold water to your condenser, right? It has to be circulating. And one important thing to note is it has to be coming from the bottom. Now, why is this, right? Well, if you take your condenser here, right? If you have water coming in from the top, it'll just flow in a little stream and come out the bottom, right? It might fill up at the bottom a little bit, but other than that, you won't get a very good coverage of the whole column. But if you actually have your water coming in from the bottom, right, you'll actually end up getting all of this filled up with water, and then the water comes out at the top. So this will ensure that the condenser is nice and cool so that the vapors will condense inside of it. Now, the next thing, you have to do your dial up to 50. Make sure to turn on the switch of the heating mantle, and it's okay to touch the inside. Just don't hold it, just so you can feel how hot it is, right? You'll notice the vapors will start to rise from the round bottom flask, and they'll get channeled through or via the fractionation column, right? And then they'll get channeled via the 3-way adapter into your condenser. All right. The vapor will be condensed inside the condenser, right? And you'll see little droplets going around. Yeah, so you have to collect your liquid in a 10 milliliter measuring cylinder. Now, you want to transfer this to another beaker, right? Because we're a little short in supplies often because people break things a lot. So we want to reuse the same graduated cylinder. Just transfer whatever you got on the first fraction into a separate container, and then collect the next fraction with the same cylinder. Uh, One other thing to note, as I mentioned earlier, do not let it become dry because it can be very dangerous with things other than, water obviously won't explode, but oftentimes you use organic solvents, and those have the capabilities of reacting with oxygen and causing an explosion, right? So you don't want that. So while you're distilling, you want to measure the temperature at each milliliter that you collect, right? This is the reason why we use a graduated cylinder or a measuring cylinder. So you're gonna take all these measurements, right? And you will notice that while you're collecting a fraction, the temperatures will pretty much remain constant, right? They'll go up very slightly, but for the most part, that'll it'll stay the same, right? And then you use Excel, of course, to draw a graph. If you guys don't know this already, Excel is really good. Uh, you might want to look up how to make graphs with Excel because if you're a science major, you'll end up using Excel a lot. So, yeah, you just basically do a graph and you'll see that it's probably going to be something very constant, right? Very small slope. And as always make sure to properly leave the lab the way it's supposed to be. So you dump your liquid waste, water goes into the aqueous waste container, methanol into the non-halogenated organic waste, liquid waste, right? It's not solid. The heating mantles always have to make sure they're turned off. Everything is tied up, your cables and everything nice and neat. Don't leave a mess. Leave everything nice and tidy. And of course, all your glassware, make sure you clean it. Try to dry it, of course, and return it to where it belongs, which is those little cases that are in each of the stations, right? Other than that, that pretty much wraps up this lab.